Alright, we ready? Yeah? No? Alright, let's look at our learning targets. Let's refresh ourselves. Remember, I had to move your learning targets over to the left, okay? So there are 3 learning targets that we did, and y'all are all looking at your papers, and none of y'all are looking at your learning targets. Gage, you ready, dear? Gage, you ready? Learning targets? There were 3 learning targets we learned Friday. What was the first one? By graphing, right? Okay, which is what we're going to do on 14. And then what about number 2? Oh, you're a lifesaver. Thank you, Justin. Use substitution. And then what about, what's the third one? Elimination. All right, y'all ready? You good to go? All right, so when we did graphing, I gave you 3 little pointers. When you did graphing, what did you need to happen before you could graph those? What needed to happen to your equations before you could graph? Look back at your notes, quit staring at your pencil, quit staring at your phone, quit staring at this, grab your notes. What had to happen before you could graph? Not standard form, no. Slope-intercept form, which means they need to get what letter by itself? Y. So our first learning target, when you graph them, you got to have Y by itself. Keep your notes out because we're going to keep going. The second one, when you do substitution, what did you have to have in order to do substitution? No. Any variable by itself, right? Any variable, X or Y, didn't matter to do substitution. Now, I think it was Brian, when we are doing elimination, what do we have to have? Perfect. Same number, same letter. Y'all okay? All right, so look right here. We got Gloria, and you got... That is Sarita, isn't it? Okay, that's Sarita. And you got Gloria. So, which one is right? Is either one of them right? Or are they both right? Oh, they have different answers. They cannot both be right. So are they both wrong, or is one of them right? So which way did they use? Did they graph it? Did they use substitution? Or did they use elimination? They used what? Garrett, were you saying something?
I was.
What did you say?
I said elimination.
You would be correct. Why would we use elimination?
Because they got the Y full.
Yeah, they got the same number with the same variable, right? Are y'all okay with that? All right, now, how would you make -4 and +4 eliminate? How would you make them cancel out? You would add. And what did both of them do? They did not both add. I'm pointing. Like, there's a reason why I'm going back and forth and pointing, guys. What did they both do? Okay, stop right now. Everybody stand up. Everybody stand up right now. Stand up. Stand up right now. We're going to stretch by using some math terms. All right, so stretch. We're stretching, and we need to make an absolute value graph. What's an absolute value graph look like? Go. Boom. Don't make travel up to B. Widen it, make it B. All right. Well, let's do. What are we going to do next? A constant graph. What's a constant graph look like? Straight out here. Where you go, Roy? All right, and what else? Oh, what's this one? Oh, that looks good. What that one? What's this one? Curve. What's this one?
That's
Square root.
Square root. Do it. Let's go. Square root. We're gonna do this way. Why can't we have the bottom part of our square root like this? Why can't we do this?
Because there's no negatives.
Anything negatives. What else do we have?
We have this.
Get off that wall.
These ones. This one.
Oh, the that maybe. Whatever X.
Oh, but what
The
about
curvy part.
Yeah.
And then the
what
bottom.
about this one?
Oh, mine's not good. I can't make the arms go. We're gonna make it like this. What about parabola? What's parabola like?
What about this one?
Parabola's not like this.
No.
There you go, Rand. Think of the ballerina arms. There you go. And like that. What else do we have? Identity. What's an identity? There you go. Like this. Or flying around the room. Okay. What else do we have? Is that the only one? We missed one? Is that all of them? Okay. Now are we awake? Yeah, let's go. Come on. Rand. All right. So what did both of them do? They did not add. They I got one person awake. There we go. So I got subtract. So they did not subtract. Take your calculator. What is -4? Subtract 4.
-8.
That is -8. That is not 0. They did not eliminate. So, is either of them correct? No. Now, ladies and gentlemen, you are in pre-AP Algebra 2 and Trig. Explain your reasoning.
They added 4.
They did not add.
Or-
They subtracted.
Wait, but they didn't subtract.
Yes, they did. They subtracted -4 and +4.
I mean, I'm saying like that. The product was subtracted. They didn't. Yeah.
They subtracted instead of added. I see what you're saying though, but that's only because of the rules. So they subtracted the y values when they should have what? Added. There you go. Y'all okay? Yes, ma'am.
I thought it was just because it's the -3.
No, it's like that. Maybe I should have put parentheses around it. Maybe that would have been better. That's probably why y'all are a little confused.
So up there,
But up there it says that it's negative 3.
yes.
It's not positive 3x.
Where?
At the
At
top.
the top it says just they're solving the system.
Oh, it does say that, doesn't it? But they still they still added right here, or they subtracted, because that would have been no. Hold on. I told you I only got 2 hours of sleep all week long. Did yes, every single week, every single day, I only got 2 hours of sleep. So I don't want to hear that y'all are tired. Hush. 3. They added. Oh, they did add. Y'all gotta keep me awake today. I know, and I'm still not even awake today. Okay. All right. So let's see. That is a -3. I'm so sorry, guys. I didn't even see that. So let's see what they do here. How'd they get 3x equals 9? What'd they do? They added. So 6 plus -3 would be 3. -4 plus 4 would be 0. 26 plus -17 is how much?
9.
9. They divided, and then should they get +3?
Yes.
Yes. Okay, let's look at this guy. So they added, and they got 3. Added, and these canceled. 26 plus -17, is that -9? No. Okay, so now that your teacher has her head on her shoulders, so who is correct? Okay, thank you. I'm so sorry, guys. So Gloria is correct because why? What'd she do wrong? Yeah, so Sarita added 26 and -17 to get -9 instead of what? Well, she should have gotten +9, right? Y'all okay? Alright, so here's what we're going to do today. We're going to do a lot of review. So now we need to review our ACT problems from Friday. Hopefully without me saying that 2 plus 2 is 5 or something this week. Good? Okay. Oh wait, no, we haven't done 14. Golly, yeah, I'm telling y'all. Y'all gonna have to stay with me this week. Y'all gonna have to be awake and keep me awake. Alright, here we go. So, x is 0. X is greater than 0. Guys, how do you graph x is a number?
Vertical line.
Vertical line, where at? Where am I gonna start?
The origin.
The origin. So right here at the origin there is a vertical line, dotted or solid since it's an inequality.
Solid.
Solid. Alright. And your x's get greater as you go to which direction? No, x's do not go up.
Oh.
To the right. There you go. Yep. Alright, then we've got y greater than 2x. Excuse me. So what's my y-intercept? 0. What's my slope? 2 over 1. So I'm going to start at 0. And I'm going to go up 2 and right 1. There you go. Keep going. Up 2, right 1. Up 2, right 1. Up 2, right 1. Or I can go the other way. What's the other way? Down 2, left 1. Is that line solid or is that line dotted?
Solid.
It's solid. Now that one says that the y's are greater than. So your y's go either up or down. Where are your y's greater than? Up. Perfect. Are y'all seeing where the shading is already starting to cross? Yeah, you see where the purple and the yellow starts to cross? Alright, we got one more to do. Ooh, when you solve by graphing, what has to happen? Y has got to be by itself, okay? So how do I get y by itself? There you go. Oh, I don't know why I'm showing you that step. 2x plus 7. So what's your y-intercept? 7. What's your slope? Negative 2 over 1. So I'm going to go up 7. And then negative 2 tells me to go down 2. Positive 1 tells me to go right. Very good. So down and right. Down and right. Down and right. Dotted line or solid line?
Solid.
Solid. Pretend like that's a straight line, not a curvy line. Alright, and that one says y less than. Y's either go up or down. So less than goes where? Down. Alright, so that's why you kind of shade a little. Well, you can see on mine.
1.4 and
Hold on a second.
3.5.
Hold on. Alright, part A said to graph, right? Y'all okay with that? Yeah, y'all with me? Y'all awake? Come on, we need to stretch again. Y'all awake? Alright, we graphed it. Part B says determine the vertices. Guys, what in the world is the word vertice referring to?
Points.
The corners, the points, right? So we're trying to look at where they come together at the points. So, do you see this little triangle right here where everything was shaded? So I know you have a pencil, but let's shade that a little bit darker so you can see where they cross. Alright, this guy's easy. What's that vertice right there? That's the origin. What's the points? 0, 0. This guy's easy. How much is that?
7, 0, 7.
0, 7. Yep. This guy's not so easy. Right? You have to find that point where they cross. Ladies and gentlemen, we did this on Friday. How do you find that point where they cross? We graphed, right? And see how it's a decimal? You'll see how it's a decimal, we can't really tell? So what were the other two ways that we used besides graphing? Learn targets, look at them. We used elimination, we used substitution, right? So what are the equations for the yellow line and for the green line? What's the equation for the yellow line? There you go. Greater than or equal to, yep. What's the equation for the green line? Y is less than or equal to negative 2x plus 7, right? But we didn't use, we use equal signs. So let's just use equal signs. Because now we can figure out what our x value is and what our y value is. So, since we have a letter by itself, what letter do we have by itself? We have y by itself, right? Actually, we have two y's by itself, but let's do this one. What is y equal? 2x. Do you see another y that I could plug that into? Yeah. So we have 2x equals negative 2x plus 7. And now I can figure out where my x value is. How do I do that? Add that 2x over and you get 4x equals 7. And let's keep it a fraction. When I divide. Alright. So I know that my x value for that coordinate is 7 over 4. And how do I find the y value? Come on, guys, we did it on Friday. Into the easiest one, Brianna. Very good. Which one's easier? The top one, get off Snapchat. So you got y equals 2 times 7 over 4. 2, I can make a fraction by putting it as what? 2 over 1. Are y'all awake this morning? Come on, you better wake your happy selves up. 14 over 4 reduces. Oh, let's keep it a fraction for right now.
7 over 2.
7 over 2. Yep. We could make those mixed numbers if we wanted to. Are y'all okay? Have I lost? Alright, here's what we're gonna do. Now we're gonna grab our ACC, now that your teacher knows what she's doing. Alright, what was it, 15? And 16. I don't have one of those. I gotta go get one. They're still on the table if you were out last week and didn't get one. Alright, 15. The only thing we're concerned about reading is just the actual question. So the actual question just asks us what? What's the actual question? Not the whole thing, just the question. What, Brianna?
Which of the following expressions represents the areas variance of the sheet?
Okay, so we're looking for what two key things? Alright, Molly, what two key things are we looking for? Because I need somebody to start answering stuff for me.
The shaded
Area and the shaded region, right? What is area? Let's see. Anna Kate, what is area? Length times width. Perfect. And then I've got to find the area of the shaded region. So, Braden, you got that whole big old picture up there, right? The whole thing. What's my length? How many squares? The whole thing.
7 or 8. 7.
What, just the length? Just how long?
8.
8. Alright. Garrett, how wide is that whole thing? 7. Harrison, just the shaded part. Just the shaded part. What's the length? How many boxes? How many? 4, 5, 6, 7, right? Yep.
Yeah, it's 6.
It's 1, 2, 3, 4, 5, 6, 7, 8 wide. And it's 1, 2, 3, 4, 5. Oh, that's only 6, isn't it? I counted wrong. And then it's 1, 2, 3, 4, 5, 6, 7 length. And then Anna, what's my width for just the shaded part? 5. Okay, so what they did was they compared the two lengths with the two widths. So Gage, what are my two lengths on this problem? 8 and 7. Okay, so Piper, which answer choices can I mark out because they don't compare 7 and 8?
A, B, and C.
Or not A, B, and C.
Oh,
Which ones don't have 7 and 8?
just A.
Just A and B. There you go. All right, let's see. Cameron, what are my two widths? 5 and 6. Okay, so you got 7 and 8, and you got 5 and 6. So Julianne, which one has the 7 and the 8 compared and the 5 and the 6 compared? E. Perfect. Y'all okay? All right, here we go. Number 16. Kenan, they already give me that A is 48, and they already give me that AB is congruent to AC, right? So in geometry, you had a formula, a theorem that said if these two sides were congruent, what do we know about these two angles? They're congruent. Very good. All right, and then Brian, in math, when I don't know something, if I don't know what these two angles are, what can I call them? X. Perfect. All right, and let's see. Peyton, how much did a triangle add to be? 180. So I got my three angles, and they equal 180, right? All right, Timothy, do you see anything that we can do to that equation right here? There you go. And you get 2x plus 48 is equal to 180, right? All right, Adriana, what can I do from there to finish solving that for x? Perfect. So I get 2x is equal to, anybody, how much? 132. And then, Avery, what can I do from there to solve for x? Perfect. And anybody, what do we get? Perfect. What's my answer? J. Y'all okay? All right, here we're going to go. You had homework over the weekend, which was page 4, numbers 4 through 7. If you hustled, most of you got some of them done in class. Yes, Gabe? You need the notes. Yep. Have you looked in the tray? I mean, not in the tray. The folder? However, was that your question too, Bobby? Okay. No, I've been here all weekend. All Friday night, all Saturday, and all Sunday. My goal is to get them graded either today or tomorrow. I'm trying. But I got Saturday school stuff to grade too, okay? Yeah, they had Saturday school. Alright, number 4. Number 4, you should have gotten -3 and -1. Do I need to go over number 4? Yes? Okay, so I got the x's to be the same. You have 4 and you have 3. What number does 4 and 3 both go into? 12. So how do you make 4 become 12? Multiply by 3. How do you make 3 become 12? Multiply by 4. You okay so far, Garrett? What's wrong? What? Do we need to go over this? So you want to wait until we do the individual work and I'll come help you? Okay. Do you want to write this down so you can make sure you get this in a minute? If you got it wrong, guys, just write the correct answer down. Alright? Here we go on number 5. Number 5, you should have gotten 0 equals 0 or something along those lines. Something where the left side equals the right side. You're not going to have time to write all this stuff down. So just make sure you write the answer down. And if they equal each other, then what do we call that? Infinite solutions. Which means if I were to graph that, because remember you could get the same answer 3 different ways. So if I were to graph that, what would the graph look like?
Inconsistent.
Very good. It would be 1,
No, consistent.
wait, if they equal each other, that would be the same line, and that would be inconsistent. You're right. Alright, and then number 6, you should have got -1 and 4. Y'all okay with that one? If you got it wrong, just scratch your answer through and write the right answer. Do I need to go over this one? Yes? Okay, so let's see. I got the y's to be the same. 3 and 5 goes into 15. So I multiplied this one by 5 and this one by 3. You okay with that? Alright, and then I multiplied everything. You okay with all that? Alright, and then I subtracted because you have 15 and 15. So 30 minus 24 is 6. 15 minus 15 is 0. And 30 minus 36 is -6. You okay with that? Yeah, that minus sign is where it gets most of y'all right there, because y'all forget to subtract everything. Is that the only thing? Okay. All right. Make sure you get that answer written down so you can get the right answer. Okay. All right. And then number 7, you should have gotten 4 and -1. Do I need to go over that one? Which one? 4 was 3 -1. And 5 was an infinite solution. Alright, then we're going to go to page 11, and we're going to work with our partners individually, and we're going to make sure we're okay on how to graph, and use substitution, and use elimination. On page 11, we're kind of skipping around a little bit. Page 11. We skipped a whole section because we're going to come back and do that tomorrow once we're okay on this stuff. Oh. Check a bunch of stuff out. Okay, on 1 and 2, what's the only thing that you need to do on 1 and 2? Graph. And we wrote ourselves a note on our notes on Friday. When we graph, what has to happen before we can graph it? Got to get y by itself. So you might want to make yourself another note on 1 and 2. Got to get y by itself. Y'all okay with that? All right, number 3. How does it say to solve it on number 3? Substitution. What do we look for with substitution? Any variable by itself, right? So number 3, do you see a variable that's very easy to get by itself on number 3?
Yes.
All right. So then what about number 4? What does number 4 and number 5 tell us to do? Elimination, right? So, and with elimination, what do we look for? There you go. Do you have that on number 4? Do you have the same letter, the same numbers with X? No? Do you have the same numbers with Y? Nope, so you're going to have to make it be that. What about number 5? Do you have the same number with H? Same number with Z? So you got to make it. 6 and 7. It says solve by either one of those. You got to use the best method. So number 6, you got a letter by itself. So I would use substitution. Number 7, I don't have any letters by themselves. I don't have anything that's real easy to get by itself. So I would probably use what? Elimination. Are y'all okay with that? And then we got a checkpoint after that. So find your partner. Let's work together. Come on, find your partner so we can get our checkpoints done. Alright guys, Peyton put up number 1 for us. Check your answer. Make sure you got the same thing as her. And let me know if I need to come around and help you, okay? Jackson, do you have number 2? Can you put that up for us? Okay. Okay. Alright, any questions on 1? Anybody need me to come help them? Alright, so Jackson put up number 2 for us. Got 2 parallel lines called an inconsistent. You're all okay? Anybody have any issues? Anybody need me to come help them? Ready to check anybody? Okay. Alright, there was one other kind of graph. What did the other graph look like? There were 3 graphs total. Yep. There was one where they crossed. One single line, right? So what was this one called when they were one single line?
Dependent consistent.
Very good. Consistent and dependent. So guys, look, there's a reason why we're going over this. 1, it's going to be on your test. And 2, this is Algebra 1. We're about to expand on Algebra 2 stuff later this week. This is only Algebra 1 right here. This is all this is Algebra 1. And we're about to expand and go to Algebra 2 later this week. So I need you to make sure that you know how to do all this. So when we move to Algebra 2 stuff, you're okay. Any questions on graphing? All right, Gabe, do you have number 3 finished? You want to come put it on the board for us? Okay, come on. And he got, so this is his answer right here. Negative 110, which most of you have. Are you all okay? Yep. Oh, we're not being quiet today. We're being so quiet. All right, Braden's coming up to number 4. All right, number 4. Braden gave us 6 and negative 3. Are y'all okay with that one? Any issues? All right, Piper, can you put up number 5 for us? Okay. All right, Piper's going to put up number 5 for us in just a second. All right, so number 5, she gave us 0 equals 3, which is not true, so it'd be a no solution. Y'all okay on that one? All right, we got 2 more to work on down there. All right, so number 6, we got 9 and 7, okay? And then, Harrison, do you have number 7? Can you put that one on the board for us?